This meeting is being recorded.
Now we're going to take a look at sample exercise 6, and we're given some information here about a buffer solution that is 0.12 molar ammonia. So this is our base that's given, and then we have 0.1 molar ammonium chloride. So this is like our base, but we know that it has an additional proton. So that's how we know for sure that this is going to be our acid. So now we have Kb given instead of Ka. So we're used to seeing two concentrations and a Ka value, but we can get to Ka using Kb. Oh, I don't know why that went up. We'll put it down here with everything else. So we can use this, or we can find Ka from Kb by using Kw. So if you recall, Kw is equal to Ka times Kb. So we can take the value for Kw 1.0 to the negative 14, and then divide by Kb on both sides. So that would be 1.8 times 10 to the negative 5th, and that will give us our Ka value. So we can use this to solve for our pH of our buffer. In part A, we're asked before the addition of any acid or base. So what's the initial pH of the buffer? So we know that pH is found using the Henderson-Hasselbalch equation. So we're going to have pH is pKa plus the log of our base over acid concentrations. So this would look like pK would be the negative log of Ka. So if you plug in the Kw divided by Kb, you would get this value here. 5.56 times 10 to the negative 10th. And this is, again, our Ka, so we have to take the negative log of that. And that would turn out to be, we'll keep some extra safety digits here, 9.255. And then this value here, we can plug in for our base, that 0.12 molar, and then we'll divide by 0.10 for our ammonium chloride, our conjugate acid. So base over acid, we see that the base is higher in concentration here. So we expect our pH to go up. So when we plug everything into our calculator, we should see a final pH here of 9.33. And when I said go up, I meant from the pKa value here, so slightly higher than that. Now we see in part B, we have our pKa value. Now we're going to add, to solve for our new pH, we're going to add some base. So our pK is the same because it's the same buffer system. So we have this value, this 9.22, plus the log of our base to acid concentration. So how do we find, after the addition of this amount of base, what our new concentrations for our buffer system will be? So we know that when we add a strong base, it will react with the weak acid and increase the concentration of weak base. So let's take a look at the values that we're given here. So my strong base is 0.005. All of that will get used up. So I know I'll have none of that at the end. My weak acid, will confirm, was 0.10 to start from what information we were given above. So now we're going to subtract 0.005. And I added an extra 0 here just to keep things lined up. And we see that this is going to be 0.095. Then we have on this side our weak base. So we started with more of that, the 0.12, but we're going to, instead of subtract now, we're going to add 0.005. So we're going to end up with 0.125. Again, my base, my acid. When I plug these values in, we're going to see pH is equal to our pKa plus the log of, the base is the 0.125, the acid is the 0.095, And we're going to see a slight increase in pH because the base is higher concentration of our buffer than our acid now. So we're going to see this turn into about 9.37 after that amount of base was added. Now we're going to add some acid. So we're going to go back to our initial buffer system and we're going to calculate the change after this addition of acid. So now we're going to add strong acid. It's going to react with the weak base. We're going to get more weak acid. So the same initial starting concentrations in our buffer. So we know that we also have the same pKa. So let's do our math here to get our base and our acid concentration. So we started with, or rather our strong acid. We use all that up. We'll get rid of this. So we know we're going to subtract from our weak base, which started at 0.120 minus 0.005. So that gives us 0.115 for our new base value. So we'll plug that in right here, 0.115 over my weak acid. So that started at 0.100. Now we're going to add 0.005. So I get 0.105. I'm going to put that on the bottom here for my acid. Now I have still a higher concentration of base in my buffer. So my pH will be slightly higher than my pKa value. So when I add these values together and then what we get when we plug this into the log, we're going to get a pH of 9.29.